Hello everyone, welcome to Aeromechanology channel. Today's topic is bonus tolerance. Definition of bonus tolerance. Bonus tolerance occurs when a feature deviates from its maximum material condition or least material condition, allowing more tolerance than originally specified. Maximum material condition refers to the condition where the feature contains the maximum amount of material, such as the smallest hole or largest shaft diameter. Least material condition refers to the condition where the feature contains the least amount of material, such as the largest hole or smallest shaft diameter. The idea is that if a hole or pin does not reach its maximum material condition size, the extra clearance or looseness due to a smaller pin or larger hole can be translated into bonus tolerance for the feature's position. Formula for bonus tolerance. The bonus tolerance is calculated as the difference between the maximum material condition size and the actual measured size of the feature. Application of bonus tolerance. Bonus tolerance is commonly used in manufacturing and assembly, where interchangeability is critical. Looser fit can be tolerated, reducing the need for tight positional accuracy. Cost reduction. Larger tolerances reduce inspection and machining costs. It is typically applied in positional tolerances for features like holes or slots, where parts need to align. Assembly operations, where having more flexibility in part position can still allow proper function without sacrificing performance. Example of bonus tolerance. Let's say you have a hole with a nominal diameter of 10 millimeters. The MMC diameter, which is the smallest allowable hole size with maximum material, is 9.8 millimeters. The positional tolerance at MMC is plus or minus 0.2 millimeters. Now when the hole is produced, if its actual diameter is 9.9 millimeters, the bonus tolerance is calculated as the actual size minus the MMC, which in this case is 0.1 millimeters. Therefore, the total allowable positional tolerance becomes 0.3 millimeters. If the actual diameter is 10 millimeters, the bonus tolerance would be 0.2 millimeters, making the total allowable positional tolerance 0.4 millimeters. When the hole is larger than the MMC, you gain extra tolerance for its position. Bonus tolerance provides flexibility in manufacturing, as achieving precise hole sizes can be difficult, but it ensures that if the hole is slightly larger, you still have more positional flexibility. Key benefits. Improved manufacturability allows for parts to be made with looser tolerances, reducing costs. Flexibility in assembly means that as features deviate from their MMC or LMC, they can still be assembled properly without requiring costly rework. Cost efficiency is another key benefit, as bonus tolerance can lead to fewer rejected parts and easier inspection criteria, improving throughput in production. In conclusion, bonus tolerance is a powerful tool in GD&T that improves manufacturing and assembly efficiency by allowing greater flexibility when the feature of interest deviates from its MMC or LMC. It is a widely used concept in industries like automotive, aerospace, and precision engineering, helping manufacturers strike a balance between precision and practicality. Thanks for watching. Please like, share, and subscribe. Happy learning!